Good afternoon, class. For today's topic, we will discuss about lesson 3, which is images formed by lenses. And can you please kindly read this part, Hermida?
Lesson 3. Images formed by lenses. Lenses are objects usually made of glass that refract light. They may form into different shapes depending on the purpose. Spherical lenses are optical lenses with curved surfaces that cause light rays to converge or diverge.
Can you read this part, Kwan?
Types of lenses. Convex lens, also known as converging lens, a type of lens that is bulging or thicker at the center, and when light passes through it, the light converges at a single point. Concave lens, also known as diverging lens, thinner in the center and thicker at the edges, and when light passes through it, light diverges or scatters. In the previous activity, the bottle with water served as a lens, also known as convex lens, and refracts the laser light. As you have noticed, the light changes its direction. This is due to change in material that light travels, from air to water and water to air. And when an object is placed behind the bottle, the image formed is different at a varying location.
Image formation by spherical lens through rays diagramming techniques. Image formed by spherical lens follow the law of refraction. We will not focus on the refraction that happens when light enters the lens and when light leaves the lens. Instead, we will look at what happened in the middle of the lens, known as the refraction region.
Parts of the diagram. Lens. It can be a concave or convex lens. Principal axis. An imaginary line that bisects the vertical lenses horizontally. Primary focus. Located along the principal axis, depending on the type of lens. For a convex lens, it is on the same side with the object, and for a concave lens, it is on the opposite side of the object. Secondary focus. Located along the principal axis depends on the type of lens. For a convex lens, it is on the opposite side of the object, and for a concave lens, it is on the same side with the object. Optical center. Located at the intersection of the principal axis and the lens.
Rays to be used. A. Incident ray parallel to the principal axis, and when it refracts, it will A. Move towards the secondary focus, or B. Follow the path along the secondary focus, F. B. Incident ray, A. Passing the primary focus, or B. Moving towards the primary focus, and when it hits the mirror, it will refract parallel to the principal axis. C. Incident ray passing the optical center, and it will continue its path because there will be no refraction.
Description of the image. The image is formed at the intersection of the refracted rays, and it can be described based on its size, orientation, location, and type. Also take note if there is no intersection because the refracted rays are parallel to each other, no image is formed.
Size. It describes the height of an image when compared to the object. It can be described as smaller, reduced, same size, larger, or magnified. Orientation. It describes the positioning of the image when compared to the object. It can be upright when it has the same position as the object, or inverted if otherwise. Location. It describes where the image is formed. It can be described as the same side of the object or on the opposite side of the object. Type. It describes the type of the image formed. It can be real if the image is formed by the actual refracted ray and located on the opposite side with the object, or virtual if it's formed by the extended refracted ray and on the same side of the object.
And that is for our today's discussion. I hope that you learned something new from our lesson, which is images formed by lenses. And have a good day and bye-bye.